In the last video, we considered that for the first time in history, we can form theories of the origin of our own solar system and support those theories with images of the origin of other solar systems. That's an incredible accomplishment. If you've watched these recent videos, you're probably now familiar with this fantastic image of the protoplanetary disk around the star HL Tauri, about 450 light-years away, from ALMA, the Atacama Large Millimeter Submillimeter Array, located in the Atacama Desert of northern Chile. To look at distant solar systems is in some way to explore them. And I think that as an accomplishment in exploration, this really is on par with the moon landing and Neal Armstrong's famous and efficient dictum,
"That's one small step for man, one giant leap for mankind."
Today I want to explore this idea of remote images and the clarity that they lend to theoretical models of the universe. But instead of looking at our solar system, I want to turn to models of larger phenomena than solar systems. The Andromeda Galaxy, the nearest galaxy to our own Milky Way galaxy, was first noted to be observed around the year 964 by the Persian astronomer Abdul Rahman al-Sufi. It was observed and studied over time, but until the 20th century, it was thought to be a part of our own Milky Way galaxy. In fact, the entire universe was thought to contain just our galaxy. This was not clarified until the 1920s, when Edwin Hubble identified Cepheid variables in Andromeda using the Hooker telescope at the Mount Wilson Observatory in California. And he showed that Andromeda, at 2.5 million light-years away, was much too distant to be part of our galaxy, blasting open the doors to seeing the universe as composed of countless galaxies like ours. Even though the debate is long settled, I like to look at glorious images like this one and reflect on the astronomers who tried to understand the structure of the galaxy and the status of Andromeda without access to such striking and beautiful images. In fact, in 1920, what might seem today like an unusual event was held, called the Great Debate, or the Shapley-Curtis Debate. It was held in 1920 at the Smithsonian Museum of Natural History, between the astronomers Harlow Shapley and Heber Curtis. It concerned the nature of the spiral nebulae and the size of the universe. Shapley believed that distant nebulae were relatively small and lay within our Milky Way galaxy, while Curtis argued that they were in fact independent galaxies, which implied, because of their magnitude, that they must be very large and very far away. While Curtis has been proven by history to have been correct, if only he'd been able to pull out this breathtaking image in the ultraviolet spectrum, the debate might have ended there. The image is a mosaic of 10 separate images taken in 2003 by the Galaxy Evolution Explorer, an orbiting ultraviolet space telescope. The color image shows blue areas of young hot stars of high mass. These blue areas reveal the spiral arms in Andromeda where star formation is taking place, and an orange-white region in the center of older, cooler stars. The Hubble Space Telescope, which launched in 1990, has of course taken many spectacular images. We tend to be familiar with incredible views of star clusters and distant nebulas like this one. The Hubble is probably the most well-known of many space telescopes that bypass the distortion of the atmosphere to capture images that could not be taken on Earth. And the weather is more predictable too. Have you seen this spectacular image of the Sombrero Galaxy? It definitely deserves a long look. Our concept of the structure of the universe, a universe of galaxies moving away from each other after the Big Bang, has been developing since Hubble's discovery in the 1920s of an expanding universe. But how about an image demonstrating the concept? It is often suggested that the most important image ever made by Hubble is the 1995 Hubble Deep Field. This at first glance seems a little surprising, as the image itself isn't nearly as captivating visually as many other Hubble images. But the image is one of the most important images in the history of astronomy. Every dot in the image is an entire galaxy. and some of the smaller dots represent light that was emitted a mere 500 million years after the Big Bang 13.7 years ago. This image is a long exposure of a tiny piece of sky area, an image that goes back to the visible horizon of the universe. This deep field is the first of other deep field images, and it's a kind of visual image of the history of the universe. Black holes have been part of the popular imagination for decades now, bodies so dense with gravity so powerful that even light cannot escape from them. I will not trace here the history or the science of black holes, but suffice it to say that no telescope has ever captured an image of one. After all, if no light escapes from a black hole, there's no light to be seen by a telescope to capture a picture of one. Most spiral and elliptical galaxies have a supermassive black hole at their center. The supermassive black hole at the center of our Milky Way galaxy is called Sagittarius A star. Its mass is thought to be about 2.5 million times the mass of the Sun. But we may be getting close to black hole images by looking at the nearby surroundings of Sagittarius A star. For years, observations of a star called S2 that orbits Sagittarius A star have shown the presence and influence of the black hole. The Event Horizon Telescope is an international collaboration designed to investigate the immediate surroundings of the black hole. It's a linked system of radio telescopes from around the globe, all working together to integrate data from multiple sources. If this works, we'll be able to do what we did with the ALMA image of the protoplanetary disk. Use an image from a staggeringly great distance away to understand something visually, more comprehensively, and with more clarity. We are such visual creatures that images such as these have enormous power to stir the imagination and to persuade. So it's entirely possible that when watching this video a few months or a few years from now, you will be able to say, I've known about black holes my entire life, but I've finally seen a glorious and indisputable image of one. I hope that will be true, and if not soon, then a little further down the road. Certainly the black hole at the center of our galaxy will still be there waiting for us. Be sure to subscribe. You can follow my Instagram, and thanks a lot for watching.